What's up, Calc fam? We talking about derivatives and data today. Right, so we're given a word problem, right? And as always, I recommend you circle, highlight, and underline important information. We got water flowing into a tank. The amount of water in the tank is modeled by some function between 0 and 24. All right, so the amount of water, where T is measured in hours and gallons. Okay, so this is the gallons and this is our time. Now, using the data, we're supposed to find W of 8. Well, easy enough. It's right in the table. I know that W of 8 is 221 gallons. All right, and I know that this is an amount of water that's flowed into the tank, right? That's what the problem told me. So when it asked me to explain the meaning of my answer, I know that after 8 hours, 221 gallons of water have flowed into the tank. All right, cool. Now we are supposed to find the inverse of W at 257. All right, so this time I'm looking for Y value, and I am asked to find the X value. So that's kind of what we're talking about here. So I look for 257, I see it right here, and I see it at 12. So I know that the inverse of W at 257 is equal to 12. And what this is telling me is that when 257 gallons of water have flowed into the tank, it's been 12 hours, or I could say 12 hours have passed. Right, so kind of the opposite, well, really the exact opposite of part A. Right, let's keep going. So for part C, I am supposed to use the data in the table to approximate W prime of 15. All right, and the reason why it says approximate is because, first of all, I do not have a function, so I cannot just take the derivative of my function. Second of all, I am not specifically given the time measurement 15, so I don't have 15 hours. I don't know anything about that. But what I can do is approximate. So I'm going to look at the closest numbers that I have to 15, or I'm going to look at the interval in which 15 will lie. So I know 15 is between 12 and 16. So I can use these numbers to approximate what's going to happen at 15. All right, so this is an application of where we need to find average rate of change. So essentially, I need to find my AROC, or my secant, I can't spell, my secant containing, okay, I can't spell again, containing t equals 15. That's what I need to find. All right, so I can do that by using what I have, which is 16 and 12. And that's good enough. And so we get 37 over 4, and this is gallons per hour. Right? Our time's on bottom, gallons are on top. Okay, so what I can say about this is that at t equals 15, the rate of change of the amount of water. So we need to be specific about what's changing. Okay, the rate of change of the amount of water is approximately 37 over 4 gallons per hour. Now, could you give me decimals? Of course, so long as you give me 3 decimal places truncated. Okay, last example. We're using the data to find the average rate of change between 4 and 20, right? Between 4 and 20. Oh, wait, this is not the last example. My bad. Okay, next example, we're supposed to find the average between 4 and 20. So exact same thing that we did in part C, right? I'm just finding f of 20 minus f of 4 over 20 minus 4. So funny that they give you this a problem after you needed it, but whatever. All right, so we end up with 143 over 16 gallons per hour. And looks pretty good to me. I don't need to explain anything, so let's move on. Right. Then it asked me if there was ever a time when the tank contained 265 gallons of water. All right, so let's go up here and look at our table. And I'm looking for 265. Okay, well, I noticed that after 8 hours, I'm at 221, and then I'm at 257, and then I'm at 294. Wow. So I know that at some point between 12 and 16 hours, I went from 257 to 294, meaning at some point I had to hit 265. And the reason I know that is because of the intermediate value theorem. So I can say, yes, yes I can. I know that W of t is continuous, right? And the reason I know that is because it says that it's differentiable. And if it's differentiable, it's definitely continuous. It's not necessarily true the other way around, but if it's differentiable, it's continuous. And I know that W of 12 is 257, which is less than 265, which was our goal, which is less than W of 16, which is 294 gallons, right? I know that it falls in between there, so by IVT, it's true. All right, let's keep going. Okay, now they actually give us a function. So this is a pretty common occurrence where you're supposed to use a table to solve several problems earlier, and then they give you a function later. So we're given a function that looks pretty complicated, right? And we're supposed to use our calculator to find a prime of 15. Okay, well this is just a, so I need to find the derivative first. All right, so not too bad. You can do it several different ways, it doesn't matter. But a prime of t, and let's go ahead and just take the derivative of the inside here by hand just for practice. I know you can do it in your calculator, but just for practice. Right, we get negative 3t squared plus 60t plus 1800. All right, you could distribute this, but you don't have to. Okay, now we can distribute it. And to find a prime of 15, all right, you can just plug this into your calculator and you should get 9. Okay, you could have also just put this as your y1 and then went to your alpha window menu and use that. But we can definitely go over that in class if you still don't know how to do that. All right, and now last example. We need to find the average rate of change between 4 and 20 hours. All right, so similar to what we did already, I need to find f of 20 and f of 4 and subtract them. All right, so remember this is AROC, what we're doing. We need to do slope. All right, so plugging this into my calculator, I ended up getting this huge mess. Ugh, that's ugly. We could simplify that. I got approximately 8.996. All right, so we're going to truncate after 3 decimals. And that's good enough for me. I will see you all later.